I am looking after pavement related works there. So today I am going give lecture on topic 1, subsoil drainage and moisture control of pavements. Topic 2, road roller, method of rolling and preparation of subgrade. So let's get started with topic 1, subsoil drainage and moisture control of pavements. So we will start from the basic definitions. What is the subsurface drainage system? So removal or diversion of excess soil from the subgrade is termed as subsurface drainage system. You can see in the photo the complete cross section of the pavements. We can see from the subgrade, separation layer, permeable base course and slope provided in the pavement and edge drain, through which whatever the water is percolated in the pavement is drained out. So first of all, we should know what is the sources of water in the pavement, then only we can drain out the water, whatever water is percolated in the pavements. So this is the photo through which water entering the pavement. Upward soil formation into a structural section through the capillaries, downward through porous pavement joint crack into subgrade, horizontally through shoulder into bases. So you can see from the photo the sources of the water in the pavement through which the road is deteriorated. So now come to what is the importance of the subsurface drainage. So why you are providing in the pavement? So to prevent subgrade failure. So excess moisture reducing the stability of the pavement, which leads to the subgrade failure. Second one is to prevent reduction in the strength of the pavement material. The strength of paving material like stabilized soil and GSB, WBM is reduced. Third one is to prevent frost sections. In flexible pavement, the formation of waves and corrugation takes place due to the poor drainage. A stagnation of free excess water in the pavement structure for long period is one of the main factor of the early deterioration of the pavement. You can see in the photograph, in granular subbase, due to the percolation of the water, the fines in the pavement in granular subbase is sinking into the subsoil, resulting loss of the strength. So where is required? So requirement of the subsurface drainage, where is actually the drainage, where is required? So when frost actions occurred in the subgrade beneath the pavement, when groundwater is expected to rise in the level of the base course, where pavement is subjected to frequent indentation and the subgrade is highly pervious. A pavement surface drain system is required to control or eliminate the ingress of water from these sources. Subsurface drainage pavement structures. So while constructing the subsurface drainage system in the pavements, there is some structure. First is drainage layer, that is generally we are providing the GSB layer. In more there are 6 type of GSBs given. Generally in drainage layer we are grading 5 and 6 is provided. Second one is the separator layer. So there are 2 type of separator layer. First is the aggregate separator layer, nowadays not in use. Second one is the geotextile separator layer. So now come next is filter material and perforated semi perforated pipe. So it is important to provide filter in the, this is the most important notes while doing such type of work. It is important to provide filter in the drainage layer and channel such that they remove water and water only, do not let finer particle wash out with water. So this is the complete structures of the subsurface drainage system which is provided in the pavement. You can see in this photograph there is a drainage layer come GSB and there is a pipe, perforated pipe, which is, this is the filter material which is called as a crush aggregate, and this is the pavement through which the water is drained out through the lateral pipe. This is the basic structure of the subsurface drainage. Now come to the how to do subsurface drainage. What is the methodology? So in first photo you can see that by providing the geosynthetic layer, we can retain the fines moving in the subsoil. So basically we are preventing the sinking of the fines due to the water using this geosynthetic layer. Second one is lowering of high water table providing longitudinal layer transverse drain pipe due to capillary water used to get into the pavement. So by this method we can lower the water table and save the pavement. Next one is control of seepage flow. This is the way to provide and prevent the water entering in the pavement. Control of capillary rise using the layer of the granule we can provide through the which water table can be lower. This is the basically the way, this is the photo, this is the geosynthetic layer. Basically, these are the way to construct subsurface drainage in the pavement. Now, come to the topic 2, road roller, method of rolling and preparation of subgrade. So, first of all start with what is the road roller, why we are using, what is the purpose? Purpose of roller is, road roller is compacting the pavement. The roller is basically, it is a definition of the road roller is the, it is a compactor used to compact the following in the construction of the road. First is soil, second is gravel, third one is concrete and fourth one is asphalt. So, what is the selection procedure? How we select the roller? It's depend on type of applications, thickness of layer, properties of material to be compacted. What is the material property? The material properties include grain size distribution, grain shape, maximum size and water content, etc. So, these are the photo of the road roller. In first photo you can see, the basically it is a compactor generally used to compact the soil, and second one is the tandem two-wheeler roller. So, the roller machine parameter include the roller weight, the compaction type may be static or vibratory, diameter and surface of drum may be sieve foot or a smooth roller. The roller weight can be increased by adding water, sand still inside the wheel. So, classification of roller. So, roller are broadly classified in the following type depending on their utility in the situations where the roller to be used. So, first is a static roller, in which there are two type of roller. First is 3-wheel roller, second one is tandem roller, that is 2-wheel roller. Next is sieve foot roller, tamping foot roller, pneumatic tire roller, that is PTR, and last one is the vibratory roller, which is available in the single and double drum. So, these are the photo of the static roller. You can see the 3-wheel roller, tandem roller, 2-wheel roller, sieve foot roller, pad foot roller. This is the PTR, that is called pneumatic tire roller, vibratory roller single drum, vibratory roller double drum. So, method of rolling, how we are doing the rolling. So, first of all we should know what is the objective, why we are doing the rolling, why we are doing the compaction of the asphalt. Here the roller may be used for the purpose of the compact the soil, gravel, concrete and asphalt. So, here we will talk about only the asphalt pavement. So, what is the objective, why we are doing the rolling? So, to increase density, reduce air void, increase stability, smoother surface. So, what is the methodology? So, rolling usually generally undertaken in the following step. First is the paver screed, second one is breakdown rolling, intermediate rolling, finish rolling and traffic rolling. So, we will start from the paver screed. The screed is the first device to compact the mat and may be operated in the vibratory mode and easily achieve compaction up to 85%. While laying the asphaltic, up to 85% compactions we can achieve in paver screed only. So, this is the photo of the roller and the paver screed. We can see in this photograph, this is the paver screed through which we can easily achieve the compaction up to 85%. So, now the breakdown rolling. So, the first roller. The rolling undertaken behind the paver screed is breakdown rolling. The density gain is achieved the most during the breakdown rolling. This is the first roller. You can see just behind the paver. Next is intermediate rolling. So, intermediate rolling is required to supplement the breakdown step in achieving the required density. This can help further compact the mat, rearrange the aggregate within the mat to make it receptive to the further compaction. Pneumatic tire or tandem roller may be used for intermediate rolling. This is tandem vibratory roller. This is PTR, that is called pneumatic tire roller. We can see in this videograph, while doing the rolling, there is an impression. There is some type of loading in the vibratory mode, static mode. So, some impression will be there in the pavement. So, we can see in this photo. This is the amplitude and high frequency, low frequency. This is the basic effect while doing the compaction of the pavement. Next is finishing rolling. So, the finish rolling is done to provide a smooth matte surface. It should be accomplished with 6 to 8 ton tandem or tandem vibratory without using vibration while the material is still warm enough for removal of roller marks. So, last one is dry fix. So, after the roller has compacted the mat to the desired density and produced the desired smoothness, the new pavement is opened for the traffic. Traffic loading will provide further compaction in the wheel path of a finished mat. Generally, while doing the construction, 100% density we are not going to achieve. Some density is for the while plying out traffic we can achieve. So, what is the factor affecting the compaction? Some are the factor which affecting while doing the compaction. First is the compacting effort, temperature, roller speed, number of roll passes, rolling pattern, bitumen content, base condition, lift thickness and the particle size. So, we can see this is the rolling pattern while doing, these are the roller. We can see how they are rolling. We can see while doing the rolling, the first roller is overlapping the, that is 15 centimeter to the subsequent layer. Finally, after rolling, we are going to check the quality. So, quality generally checked by the density. The density, there are generally two methods available to check the density of the mat. First is the nuclear or non-nuclear gauge, and second one is by using the core cutting. So, next topic is preparation of subgrade. So, as you know, the subgrade is foundation of the pavement structure on which the subbase is laid, entire subbase is laid. Preparation of subgrade consists of all operation before the pavement structure and could be placed over it. The subgrade may be situated on an embankment or excavation or at native surface. Subgrade are commonly compacted before the construction of a pavement and are sometimes stabilized by the addition of the lime, Portland cement or the other method. If native soil is not meeting the criteria as per the Indian standard, so generally sometimes we stabilize the soil, existing soil by adding the lime, Portland cement etc. as per the requirement or other modifier. The normal design parameter which are associated with the subgrade soil are the maximum dry density, optimum moisture content and the California bearing ratio, that is the CBR. The next one is the basic parameter is the dry density of soil, which increases with the compactions and with addition of the moisture content. The moisture content at which maximum dry density is obtained is termed as the optimum moisture content, that is the OMC. So, in all above cases, the side clearance, clearing, grubbing operations should be done before starting the pavement structure. After that, grading operation is started as per the design and drawing of the pavement plan and the profile. So, we can see this is the operation. First, this is the grader grading the soil, maybe the embankment, maybe or native soil. After the grading of the soil using the motor grader, we use the roller. Soil compactor basically is called the soil compactor, is compacting the soils, and you can see the after the complete process you can see the subgrade preparations. So, what is the methodology? What is the methodology for the subgrade constructions? So, first we will start from the excavation while doing any type of work. So, preparatory work will be there. So, while doing the preparation of subgrade, so first of all we will start the side clearance, excavation, compaction of the native surface, subgrade up to required depth, construction of subgrade layer with approved and specified material obtained from approved borrow area or suitable material from road excavation in accordance to the clause 305 of the MORTH. After completion of side clearance embankment, the limit of subgrade shall be marked by fixing peg on both sides at regular interval. The working benchmark shall be set outside the limit of the construction area. Then after that, all the preliminary work, the selection of the material. The soil material used for subgrade construction shall be soil, muram, gravel, reclaimed material from the pavement or mixture of these. The subgrade should not contain material from swamps, marks, logs, stumps, perishable material, any soil classified as oil, OI, OH, PT or material susceptible to the spontaneous combustion, clay having liquid limit exceeding 50% and the plasticity index exceeding 25, and material with salt resulting in leaching, expensive clay exhibiting marked swell and shrinkage properties, free swelling index exceeding 50% shall not be used in the subgrade for the airfield pavement or any road. So, material used for the subgrade construction should have maximum lab dry density when tested as per the IS 2720 part 8 not less than 17.5 kilonewton per cubic meter. In case the available material soil failed to meet the requirement of the CBR, use of soil sterilization method as recommended. Refer table 5 of IS 1 for 98/1970. So, what is general equipment being used while doing the preparation of the subgrade? Hydraulic excavator, dozer, dumper, motor grader, we can see in the previous photo. Vibratory roller, this is also we can see in the previous photo. Water tanker, tractor trolley, and the last one is the survey equipment. Method of the operation. So, after completion of the embankment, the limit of subgrade shall be marked by fixing pay at the regular interval before commencing the earthwork. The embankment subgrade top shall be leveled to facilitate placement of the first layer of the subgrade mixed with the water and then compacted by the rolling so as to achieve minimum dry density as specified in the specifications. Unsuitable material occurring in subgrade foundation shall be removed and replaced by approved material and laid in layer and suitably compacted to the required and specified degree of compaction. Next one is the subgrade material shall then be sprayed in layer not exceeding 250 mm compacted thickness or as directed by the engineer using motor grader. The compaction shall be done with the help of the vibratory roller of 8 to 10 ton capacity. Compaction trial shall be carried out on a suitable stage to determine the number of the passes required for the particular type of soil to achieve density as specified in the table 302 of the MORTH. So, first we will make the trial and how much passes is required to achieve the required density as per our specifications. After that, we will start the work. Subsequent layer shall be placed only after the finished layer has been tested as per the clause 903 2.2 and accepted. So, top level of subgrade shall be checked with the reference to the longitudinal or the cross profile of the road as per the drawing to keep the variation within the tolerance limit as per the table 901 of the MORTH. So, what is quality control? At the end of the compactions, as per the Ministry of the Road Transport and the Highway, that is MORTH, specifications subgrade and shoulder should be compacted to 97% of the maximum dry density using heavy compaction. The load bearing capacity of subgrade is measured by the CVR test, falling weight deflectometer, back calculation and the other method and form the basis for the design of the pavement. The load on the pavements are ultimately received by the subgrade for dispersion to the earth mass. It is essential that no time the soil subgrade is over stress. So, these are the frequency and type of the test and the reference of the code to be done as a quality control. First is sand content gradations is the procedure already given in the IS 2720/4 and its frequency is 2 tests per 3000 cubic meter of the soil. Next is the utter work limit. Reference code is IS 2720/5 and its frequency is 2 tests per 3000 cubic meter of the soil. Third one is the modified Proctor test is also referred the IS 2720/8 and its frequency is 2 tests 3000 cubic meter. And next is moisture content IS 2720/2 and 2 tests per 3000 cubic meter. CVR test for subgrade soak conditions. There are CVR tests done in the two modes in the soak condition. In this method, we will do in the soak conditions. The IS reference code is 2720/516. One test and its frequency is 1 test for 3000 cubic meter. Next one is density of the compacted layer and its frequency is 10 test per 3000 square meter. These are the frequency given as per the MORTH specification. And last one is the deleterious content is the IS 2720/27 as and when required by the engineer. So, this is the photograph of site by checking the density using replacement method, sand replacement method and the field CVR and K value on the prepared subgrade. So, this is the basically after completion of the formation, the road structures is like this. First is the bitumen pavement. So, we can see in this structure, this is the subgrade on the native soil or splage or field earth. Second one is the GSB, third one is the wet mix, fourth one is the bituminous base binder course, maybe DBM or bituminous concrete 1, and last one is the bituminous bearing course grading 2, and next is the concrete pavement. The structure of the concrete pavement is like this. You can see in this photograph, in these slides, the pavement quadratic until polythene frame, sand layer, dryland concrete, wet mix, macadam, granule subbase, and the compacted subgrade on native soil or splage soil. I hope whatever I covered in my video will get fruitful during planning and execution of pavement works. Thank you. Jai Hind.